Okay, we'll go ahead and start now, since it's 10:30. Welcome to the data center portion of Ignite. And I'm going to spend some time talking about challenges of doing security in data centers. Data centers is a broad topic, and Palo Alto has spent a lot of years focusing on enterprise networks, and then lately on public cloud. But for the last 5 years or so, traditional data centers with big iron and virtual firewalls has been a big part of our business. But data centers can take a wide variety of forms and plans. My job is that I spend my time traveling around the world talking to different customers about how to do data center integration. And I find that the themes are largely the same, no matter where you go. I was in South America a few weeks ago, then I was in Egypt, and I actually visited the Vatican. And they all have data centers, and they all face the same challenges. I tend to talk about this from a network-centric perspective. I'm a CCIE, so I tend to come from that side of the world, and I'm interested in packet flows and how do you actually see what's going on, because traditional route switch data centers are relatively easy, but now with virtualization and tunneling and ACI and NSX and private cloud and all this magic, the challenge is how do we actually maintain visibility into a completely dynamic environment. Now, I usually have a question. I'm curious, how many people here are planning to stick with their traditional data center, not go greenfield? Like how many people, actually, let me ask you a second question. How many people here have a greenfield, brand new data center you can build from the ground up? Okay. So that's easier. When you talk about SDN and these kinds of private cloud environment, that's good. Now, how many people are going through sort of the data center refresh and considering NSX and ACI and OpenStack? Actually, how many are not? Okay. I do run into some customers who just don't have no interest in it. I mean, they're very conservative. The network has run the way it runs fine. They're running RIP. Why break it? So we try to maintain, or at least I try to maintain a largely agnostic approach to this. I mean, I work for Palo Alto, but the idea of putting security into any of these environments has to be scalable and can't really be tied into any one technology. So I'm going to try to describe how security is traditionally done and how we can still do that, and how we want to evolve into this magic world called cloud, right? Because almost nobody agrees on what that means. A lot of people are, these solutions are purchased at the high end by CTOs, and network operations teams are expected to implement this. And the challenge is how. So the agenda quickly is, what are the security challenges unique to data centers? I describe kind of the difference between enterprise networks and data center networks, in the sense that the enterprise networks have users doing bad things. Clicking on email links, surfing on websites, using Facebook. There's a lot of interactive traffic going on in an enterprise network. So when we talk about what Palo Alto firewalls do, we like to talk about things like blocking Facebook posts, using games, things like this. But in data centers, you generally don't have users sitting in there. We're hosting services. So in that sense, it's a bit more of a static environment. You're accessing a service and then coming back in. And the traditional security model has been perimeter-based. I have a perimeter between the outside and the inside. I will secure that, but I control my internal network. So do I really actually need security in my data center? Not everybody has the luxury of a greenfield data center. Those that do, you can build it from the ground up and build a nice cloud architecture and put in ACI or whatever. I'd find more customers, though, they have an existing data center, and they need to somehow scale it towards this future cloud thing where all your problems will be solved. Right? And what are the security challenges in both of those? Cloud architectures have security issues that are somewhat different than traditional firewalls. So firewalls have been around for about 20 years. And when you have a static route switch environment, where to place that firewall is really a question of where do you put yourself in line to see traffic. But with cloud, you're dealing with tunnels and APIs and virtualized instances and vMotion going on. Scalability, interacting with hypervisors. So the security environment or challenges in a cloud environment are different than a traditional environment. And I'm going to give three real examples. I want to give three real-world customer examples of customers who have had to have an existing data center and have had to migrate without buying a new data center. And then I'm going to include a bit of a security migration checklist. When you plan to do this, what are the broad steps that you need to follow in order to scale into this future design? And also some resources. So the first question is a question that I find a bit obvious, but a lot of people are still, especially networking people, are still in this old world model, and that's the perimeter security model. I have the outside, which is either the internet or the WAN, that's untrusted. I have my data center, that's trusted. I have a layer 4 firewall, I'm safe, right? So this is a network-centric view of security, which is packet switched, access lists, just looking at the port. The majority of data center breaches that we've seen in the last many years have not come from the outside. They've actually come from the inside, whether it's deliberate or accidental. It could be as simple as, me taking my laptop home, my son plays some games, doesn't even know he's downloaded malware. I take it in the next day, plug it in my data center, and malware has entered it, no matter how nice my perimeter firewalls are. So we want to be able to do layer 7 inspection. So we don't want to necessarily trust the TCP port. We want to be able to look deep into the data payload at wire speed. So we want to do a lot of deep inspection, but not create a bottleneck. And networking people like myself have often perceived firewalls as a potential bottleneck. It's just one more thing to troubleshoot in the data center. So let's put it out there at the perimeter and not worry about what's going on inside. But a lot of recent breaches like Target and Home Depot, they've all had firewalls, but layer 4 is just, it's not useful in today's modern malware environment. We need some kind of layer 7 inspection, but without any performance hits. So if we're going to push security deeper in the data center, how do we do that without adding more complexity? We can put a lot of firewalls in our core along with our routers and switches, but now we have to ask ourselves, do we want firewalls participating in BGP and OSPF and spanning tree and these kinds of things? Or is there a way to somehow push security deep into the data center as close to the source of traffic as possible? So virtual firewalls come into play here. We could put virtual firewalls into VMware or into virtualized environments, do our inspection before any networking happens. So this is a zero trust idea. We want to implement a zero trust model without adding to the network complexity in the data center. Now, how do you define perimeter? I'm going to talk mostly about data center and private cloud, but a lot of this is driven by public cloud. So public cloud, that's not an alarm, is it? What's it? Okay, I'm going to assume it's not an alarm. This whole direction of cloud and private cloud is really a reaction to public cloud. So in my past life, I've dealt with shadow IT environments where we have a nice functioning data center, but the developers have gone out to Amazon with a credit card and a web browser. In a few minutes, they have instant resources outside my network, and now my perimeter is no longer my network perimeter because the content that I think is inside is now outside, and it can vMotion back and forth. So the perimeter is no longer a network perimeter. When we talk about perimeter, we're talking about wherever your content is. So if you have content in your private data center, you have content in some kind of public cloud, now you have software as a service like Dropbox, you can't put firewalls out there. But users might be actually putting content out there. So the job of a data center, or the definition of a data center perimeter now has become very fuzzy. So how do we address that? SDN is a big buzzword in data centers, software-defined networking. Software-defined networking will solve all your problems, right? It's the new shiny toy that everybody has, but nobody's quite sure exactly what to do with it. I've tried to explain SDN to my mother. My mother's 75 years old, and she is still, her question is always, why? Okay, it sounds nice, but why? I tend to describe virtualization as, you have three resources in the data center: compute, storage, and network. And companies like VMware have been virtualizing the first two very well for the past 12 years or so. They can virtualize compute, they can virtualize storage. But the network has been kind of this black box. That's something that they don't really provision. VMware doesn't provision network resources. So if you have a hardware firewall out there, and you have VM to VM traffic going on, you have, for the hardware firewall to see that, you have to somehow steer traffic out to it and back in again, or simply be blind to that back and forth traffic, VM to VM. I was at Facebook a while back, and we did an analysis to see the ratio between north-south traffic to east-west traffic. And we found that for every 1 megabyte of north-south traffic, that triggered 20 megabytes of east-west. And there were only hardware firewalls, which means that the hardware firewalls only saw 1/20th of the traffic going on in the data center. So SDN is largely one question, I think, with multiple answers. So the question is, how do I virtualize a network? And one answer is NSX. I'll do that from a systems layer. Another answer is ACI. I'll do that from a network perspective. Other questions are OpenStack based, where it's an automation answer to that question. Arista has. So there's multiple answers to this question. How do I virtualize a network? And now the network topology becomes a programmable resource. This can all be automated, which means that people with CCIEs like myself have to learn scripting. We have to learn Python. We have to learn how to automate network resources along with compute and storage. How do you do security with that? So these are a couple of examples of how traditional data centers do security. And this is probably the most common one that's been around for 20 plus years. Just do it at the perimeter and don't do anything in the core. And I see a lot of environments that are still like that. So this is a very simple drawing, but this circle just is supposed to represent a complex data center with routing and switching going on, and there's security only in one place, at the perimeter. I assume my internal environment is trusted. But all you got to do is look at the recent breaches to find out that all the great ones have gone in through a layer 4 firewall at the perimeter and been a complete waste of time. Okay? So we want to somehow not do this. But this is the most common scenario. And you can still do that. I mean, Palo Alto makes some big iron boxes which you can put out at the perimeter. But the assumption is that that's no longer your perimeter. Your perimeter is wherever your stuff is. Another approach is this, which I have implemented in the past. Create a common core somewhere and put all your network appliances there. Your load balancers, your firewalls, your web caches, your whatevers, and then just steer a lot of traffic in and out of it. So if host 1 wants to talk to host 2, steer it out to a common core and then steer it back. And there's nothing wrong with this design. This is actually used by some SDN approaches, but it does create some challenging troubleshooting scenarios, because now you have a lot of trombone traffic going back and forth, and if you have vMotion events going on, now that trombone traffic is even worse. But still, it does push security a little bit into the core, away from the perimeter. This is one I've seen a few times, which just forget firewalls. Okay, just put something on the host itself, and often that's IP tables. Just put IP tables on the host to do inspection before it ever leaves. Now, this is actually a form of the zero trust model, where step 1 in the life of the packet should be policy. So whatever my architecture is, the packet is born, policy is inspected, and then it enters my core. Now, IP tables is layer 4. So it's a good start, but it's really not moving beyond the layer 4 concept. But I do see this sometimes. Firewalls are just too complicated, so just do it at the host with IP tables. So a traditional data center works like this. If these are routers and switches, and I put a host on the left side of this diagram and another host on the right side of this diagram, and I do a trace route, the next hops are going to be the next hop router. So the first hop will be router 1, then router 2, then router 3, and then the host. Right? But for a variety of reasons, SDN or cloud has implemented hypervisors as really the logical edge in the network. Okay, so there's often virtual routing, virtual switching going on inside of a hypervisor. And we want to use tunneling, VXLAN being the most common. If I now have a host at that hypervisor, and I have a host at that hypervisor, and I do a trace route, my next hop is not going to be any of the underlying routers. My next hop is going to be the destination. This means if I have hardware firewalls down at the bottom, I will be blind to that. And in most data centers, that is where the majority of new hosts are deployed. In the old world, if you needed a host, you ordered one, you waited 4 weeks, rack mounted it, and maybe a month later they'd be available. But with VMware, you can spin up VMs all over the place, and with NSX you're tunneling. And the hardware firewalls are just not seeing any of that. So we have to somehow do security both here and here. So this is why our broad data center security story is never just virtual firewalls and never hardware firewalls. It's going to be both, but they somehow have to synchronize with each other so that they all have the same picture of the network as things change dynamically. Because in traditional data centers, you have change control. So if anything changes in the data center, you have to touch the firewall. That's usually a manual process, ticketing, change control, wait for a change window, and 2 weeks later, you've made a change. But the assumption is here that this is happening dynamically every hour. So we want the firewalls to somehow react immediately, in real time, to the underlying fabric. This can get very complicated. So this drawing is complicated deliberately. But this often involves redesigning your core. The traditional data center core has been based on the old Cisco idea of core distribution and access, the kind of the onion layer. But now everything is pushing towards the clause architecture, the spine leaf architecture, so that now, no matter how big your data center is, no destination is more than 3 hops away. Okay? Down here, when we deploy firewalls, we're going to be talking about things like equal cost multipath routing, OSPF, BGP, high availability, traditional route switch stuff. This is the underlay network. Now when you implement some kind of SDN or cloud idea, you end up with an overlay network. And now you have additional vectors or layers of stuff going on that you need visibility into. So this is sort of the systems layer with hypervisors forming their own topology. VXLAN is just one tunnel type. There are others. And then on top of that, you need something to orchestrate all this, OpenStack being a very common approach to this. So at the top of this layer, you have OpenStack orchestrating everything. You have hypervisors with virtual instances of all the physical stuff, virtual firewalls, hardware firewalls, and you want some kind of central way of managing all this. This gets very complicated. A lot of people look at this and give up and just expect to be hacked. I encounter some banks who look at this and decide, okay, we're going to leave the front door open and we're just going to watch for unusual behavior. They assume they're going to be hacked. But if you do this, realize you're actually creating multiple vectors of bad things to happen. So a lot of SDN is about separating the control plane from the data plane and treating them completely independently. And we often talk about firewalls down at the data plane. But if I want to do something bad to your network, you can protect the data plane all day. But if I can access your SDN controller and turn it off, I just broke your network. So you need to protect that. You also have the management layer. This is where your jump hosts might live. What if I break that? So you actually, with SDN, you are gaining a lot of flexibility and elastic options, but you are creating now more places where bad things can happen. So this makes a security picture multi-layered. So we have to address all three of those. If you want to make your private data center behave like a public cloud, these are really your vendor options today. I've listed them more or less in order of popularity that I see. So NSX was really the first approach to this question. How do I virtualize the network? So VMware purchased Nicira, made some changes, put out NSX, and NSX said, we will just simply tunnel across the network, no changes needed to your physical network. Cisco's reaction to that was they don't like that idea because they make a lot of money off of intelligent hardware. So their approach was ACI, which is we'll do all that, but from a hardware layer. It works the same way, but you have to use all their own gear. Arista has a couple of options, which is quite new, actually. This is similar to ACI in some way. By the way, is anybody here using Arista's CloudVision solution? OK, great. What's interesting from our perspective is that in all of these technologies, the network topology is defined first, and at some point, traffic is pointed to a firewall. A firewall is stitched into a service chain somehow. But the decisions first are in the network, and second in the firewall. With Arista's CloudVision, you can actually reverse that, where you can, on the firewall, define what traffic you care about. I want to see the following 10 flows, and you can tag them with, say, the word Arista. Arista CloudVision can then ask the firewall, give me any tag rules, and then it'll build the topology based on what traffic the firewall is interested in. So it's actually consuming rules and defining the topology that way. So this is an interesting alternative approach. You, the security administrator, can now actually influence what the topology of the network looks like. OpenStack is a completely different conversation. These other options are vendor specific. They work. They have solved all the problems, and they're expensive as hell. So people often look at the cost, and they choke, and then they go to OpenStack, because OpenStack is free. But this is complicated. I see a lot of customers do that. It's generally service providers. If you have a room like this full of engineers, then you can implement an OpenStack environment. But generally, enterprise environments don't have those kinds of resources. But still, we want to be able to react to that. And that's really not kind of a cloud solution in itself. OpenStack is really an automation platform. So we want to somehow integrate with all of this in an agnostic form. We do not want to be tied to any specific environment. We want some kind of common themes in how we interact with all of these. So this is an attempt to show everywhere your data can possibly live. So in a traditional data center, all your data lived here. And outside was either your WAN or your users. But now public cloud means that your data can be in both sides of your network, and your perimeter is no longer that edge. The perimeter is wherever your stuff is. Software as a service is different. I can put firewalls in the two bottom clouds. I can't put a firewall in Dropbox or in Gmail or in Office 365. I need to somehow track that in a way that doesn't rely on firewalls. So the physical topologies no longer define your boundaries. Virtualization, tunneling, and APIs are now usually how these conversations proceed. Traditional data centers, we talk about BGP peering and OSPF decisions and spanning tree and things like this. But with public cloud, or any cloud, you're really blind to what's going on underneath. And now you need to talk about these other concepts as they apply to security. And the goal here, ultimately, is to have one common fabric where everything works exactly the same, and my content can just cloud burst in vMotion all day long. How do you do security that way? Firewalls traditionally write policy looking at IP addresses. But in this kind of environment where your data is flying around, IP addresses are changing constantly. So we have to write policy based on something else. What is that if it's not IPs or VLANs? So in order to have one common place to look at all this, you want some kind of cloud service to monitor all of this. Now this is our Aperture and Wildfire service, but other vendors have similar concepts. But the idea is that you can write a policy centrally, and you can apply that policy in software as a service using APIs, and you can push that same policy down to actual firewalls that reside in these environments. And they can all be synchronized and all share the same visibility and the same reaction to malware. Now, our Wildfire service connects to all of our products around the globe. So if a virus appears in Japan this morning, within 5 minutes, all firewalls around the planet are updated. So this service is useful for just data centers, but it does apply to everything else. Okay? It also does compliance monitor, what I call babysitting, really. It'll also monitor bad decisions in public cloud. In public cloud, it's very easy to make mistakes, like to create storage containers that are wide open, or SSH keys that are not rotated, or bad passwords. So these services will actually monitor those concepts in addition to dealing with unknown malware. We pitch this really as a solution for how do we deal with unknowns. We have a large set of signatures for malware, but there's new malware going on all day long. So we want to be able to react to new malware entering our data center, pushing it up to our sandbox, and as quickly as possible updating ourselves to that zero-day malware. So this conversation really is broader. I'm going to focus just on the data center, but there's no way to avoid this. I spend time in the Middle East sometimes talking to countries there, and they often have a perimeter-based security model where no packet shall leave their national borders. So they could care less about public cloud. They say, we will not talk about public cloud, we will never use it unless there's a cloud service in our country. I ask them, are you using Office 365? They say yes. I say, you're already using the cloud, right? Didn't occur to them, right? So this is why even people who say they will never use a cloud need to think in this broader scale. So this is sort of a mind shift as we data center people slowly evolve into the future. Okay, so the main goals that we have in a data center security architecture is we understand we need layer 7. Layer 4 it doesn't work anymore at layer 7, but firewalls can be slow. Firewalls are famous for as you turn on additional services on additional blades, performance becomes crap, right? So you just turn on the minimal amount of service, or you have multiple boxes where I have, vendor 1, vendor 2, vendor 3, each doing something different. And so this seems like I have a better security posture, but now it becomes harder to correlate security incidents because each one does logging differently, each one has a different portal, management portal. How do I implement this somehow into one box without impacting performance? I also want the firewalls to react to any changes in real time. Change control does not scale in a cloud vision, right? Manual change controls where you wait 2 weeks, and I've worked in companies where it takes 2 weeks between request and firewall change. When you have vMotion events going on and cloud bursting, you need to somehow expose your firewall's APIs to the surrounding fabric and allow your firewall to be managed somehow in real time. So if a hypervisor like NSX spins up some VMs, we want the firewall to immediately be updated. But we also want to be able to write policy independent of that information. And this is where tagging comes in. So NSX and ACI and public cloud are all able to tag workloads with information about what's actually running in that workload. So a VM is spun up, and one tag can be applied saying Ubuntu is running on this workload. Another tag says the SharePoint is running on this workload. Those tags can be sent to our firewall, and we can write policy based on that. Okay, not the IPs. So this means we can write security rules that look more like human sentences. So instead of block of IPs can talk to block of IPs, it'll say essentially anything running Ubuntu and SharePoint can speak FTP to New York. All right, and we write our policy once. In the background, we are getting this information about IPs, changes to IP addresses, new IPs, IPs being spun down, but as long as they are mapped to these tags correctly, we're not updating our firewall. We're basically writing policy once, and then our network scales, and we're not updating our firewall. Okay, I'll show you a quick example of how that works. But that's very important in this kind of model where I have lots of clouds and lots of data centers and things flying around. I can't constantly be updating my firewall. I want to write policy once and then stop, which is that. Also, this is another issue that I run into. Again, this seems very obvious to me, but I still see a lot of blacklisting approaches. Firewalls are often configured based on what I don't want to see, and default allow everything else. Whereas you want to whitelist. It's a much better approach to define what you do want to see and default deny everything else. This, to me, seems obvious, but I do often see the old model a lot. Whitelisting, not blacklisting. So performance. Most firewall vendors have had firewalls for about 15, 20 years, and they have been layer 4 firewalls. Now, as those products evolve, they have an interesting challenge. They want to add your vendor X, and you add URL filtering. You now add malware inspection. You add antivirus filtering. Usually, the packet flow architectures are such that the packet enters the firewall once through engine 1, then it has to be reconsumed and entered through engine 2, and then reconsumed, and then go through engine 3, and it's basically being digested multiple times before the packet is spit out. And each time it does that, each time you turn on these modules, performance takes a big hit. So performance throughput often drops as you turn these options on. Now, we have sort of the luxury of being a relatively young company, and we have written our code from day one to be basically a parallel approach. So a packet enters our firewall, and we will duplicate it and do all this inspection on it in parallel, and then basically recombine it and spit it out. So we can avoid a lot of these performance hits that way. Now, there are some things that will affect the performance, like SSL decryption, certain tunnel termination. But we can avoid a lot of these performance hits because we have thought of this from day one, as opposed to taking a legacy firewall from 20 years ago and somehow adding layers to it like a pancake. So, again, to reiterate, APIs are one of the most important themes in this our argument. We want to expose the entire firewall's command set via REST APIs. REST is the most common API out there. There are others. REST is what's used by basically most of the world except Microsoft. So we want the underlying environment, either the controller, and this would be an for instance, NSX, has our APIs already present in their controller. And as it makes changes, it can push information out to us. In other environments, we can send API calls out to the fabric, like Amazon, and ask for this information. So, and the information is two things. We want our policy to be updated in real time without a human needing to hit the commit button, and we want those tags. So as controller X says, I have 2 tags, and I have IPs, members of these tags, give us the tags, write the policy based that way, and in the background, we can deal with updates to those tags, but without having to rewrite our firewall policy. So this is my attempt to kind of show this. This is an example. So on the left, this is actually the Nuage controller. And in this example, I've created 2 tags, one called DAG internal and one called DAG untrusted. Each tag has 2 IP addresses mapped to those tags. This is Panorama. Now, I know you can't read this, but what this is showing is that I have created 2 dynamic address groups here with the same name as on Nuage. So I have DAG internal, DAG untrusted, same names. Now, if I click on those 2 in Panorama, I'll see that each one has 2 IP addresses that came from the controller. All right, now when I write my policy in my firewall, where I would normally map that policy to an IP address, I don't do that. I map that rule to this name. So if I look at my policy, I want to do all this inspection to tag 1. I want to do all this other inspection to tag 2. Now, in the background, we're keeping track of the forwarding tables with the controller. So if Nuage spins up new VMs and adds them to these tags or removes them, it will update that in the background. And that last step is my favorite because if VMs or IP addresses are released, it will send API calls to us and say, pull them out. Because in my experience, firewall rules never get smaller, right? They only ever get bigger. This means that there's sort of this house cleaning going on in the background. And this also reflects the way troubleshooting is reported. So in my past data center life, people would say, my SQL server's broke. They can't talk to New York. My first question is, OK, what IP addresses are we talking about, and what are the ports? Of course, nobody has any idea. We have to do research, and it prolongs troubleshooting. But this way, I can write rules based on the way the developers or users perceive the network. So I can write a rule that says SQL servers can talk to New York, but not London. They can do SharePoint, but not FTP. And that's usually how troubleshooting comes in. So I can map the troubleshooting ticket immediately to the way I've written the rules and significantly speed up troubleshooting. This tagging works in public cloud and private cloud. This is actually required by NSX. It's an option in ACI. It's an option in OpenStack. It's used in Amazon. It's used everywhere. So if you have multi-cloud environments, the key to this is create the same tag names everywhere. So tag 1 and 2 in your private cloud, tag 1 and 2 in Amazon, tag 1 and 2 in Google. And now Panorama, in our case, is our management portal, is the central point that's talking to these controllers. So if any of these environments makes a change to a tag membership, it forwards it to Panorama, and Panorama forwards it everywhere, to both virtual and hardware firewalls. And that's also important because we want hardware firewalls to be able to make decisions locally without having to forward them up to some cloud environment, extending the vectors in which bad things can happen. So this tagging concept has been around for a while, but it's now become much more critical in terms of security scalability as you create these super hyper-converged data center architectures. So this introduces a new concept of segmentation. Now, security is much more than segmentation, but a lot of customers come to us and say, we have a flat data center, and we need to segment. But I don't want to re-IP my network. I don't want to add new VLANs, because that's normally what's involved in segmenting a network. I need to create some new VLANs. I need to create some subnets. But this idea of tagging introduces a third concept of segmentation. So I can actually keep my flat network topology, tag my workloads, and now decisions can be made based on the tags. So in the case of NSX, forwarding decisions are made based on the tags. And in the case of security, we're making security decisions based on the tags. And this avoids re-IPing your network. Because data center people like me hate doing that. It's just really time, resource. It's a pain in the ass. Yeah. So whitelisting versus black. I love this picture here because this lists all the things that you are not allowed to do, but this person's found a loophole. Right? This is what blacklisting does. So instead of spending all your time writing everything you think is bad, just change your thinking and write everything you want and default deny everything else. Okay? This is a much more scalable approach. Okay, so the challenge in doing this, so you understand after a while, okay, I need to do this somehow. My old legacy architecture doesn't work. I need to somehow implement this SDN and cloud stuff. But what exactly is involved? So the challenges are operational often. Networking teams are very resistant to change. Networks are hard enough to manage. And then now a security team comes and says, okay, I want to implement some firewalls on your design. We say, maybe later. We have enough to do. We don't want to change our operational model. And often these SDN architectures move a lot of intelligent networking up away from the networks layer and into the systems layer. So now there's stuff going on in hypervisors, whereas the networking teams are managing switches and routers. But now there's actually forwarding decisions being made in the systems layer, in VMware. And now my network edge has been pushed into an operational environment that I don't have access to. So often a lot of these challenges are operational. They understand the technical benefit. But it sort of reminds me of the old voice over IP days where the telecom people were here and the data people were here, and you have to solve those problems. So that's more of a political challenge. So VMware first came out with NSX. This was an approach to basically provision networking from within the hypervisor. If a company has a systems team that has more clout and more influence, they prefer that. They're familiar with VMware. NSX is complicated, but it's still a VMware concept. So they will choose VMware and try to implement that on the network. Networking teams, like Cisco, they're familiar with that. So when ACI is demoed to them, they might find that very complicated as well, but it's made by Cisco and they trust them. So often these decisions are made based on what people are familiar with because the solutions are pretty much the same, but the plumbing is very different. We want to do security in an agnostic way. We want to be able to interact with both of these. I talked to a customer recently that actually had to implement both ACI and NSX together. They had two CTOs. One CTO bought NSX, another CTO bought ACI. Both CTOs left the company and handed both solutions to the networking team, and they had to do ACI on top of NSX, which to me is a nightmare. You have an overlay on top of an overlay. But how can you do it? I mean, there are some white papers out there to do exactly that. I would never do it, but you can. We want to be agnostic, so we say, fine, you do that. Well, how do we do security? You have two controllers in such a picture. Which one are we talking to? So we have to have guidelines for super complicated solutions. Also, migrating any data center is perceived as being disruptive to business continuity. And this is especially true if you're a company like eBay or a bank, where data moving in and out of your network equals money. I was working on a POC with a customer in South America recently with a vendor I won't mention, a networking vendor, and they tried to migrate to the new architecture, and it failed, and they migrated back. And this took 20 seconds. They migrated from the old architecture to the new, and within 20 seconds, the whole data center broke, and it took 12 hours to remediate it. And this was a financial institution. It was a big problem because every minute was counted in terms of how much potential revenue did we lose. So enough of these stories come out there that actually pushing this into production is scary. Who's going to stick their neck out and risk their jobs to do this? So a lot of these data center migrations the challenges are largely political, sort of layer 8 problems. Okay, so here are three customers who have actually done this. These challenges can be overcome. Sometimes it requires a reorg to solve those political problems. The security portion is what I would call probably the easiest of this. If you're going to implement ACI or NSX or OpenStack, all of those solutions are complicated. Security is relatively straightforward. I rarely see an environment where the security portion is a headache. It's usually something else. But I want to show three examples of customers that did not have the luxury of a greenfield data center. They have an existing data center and they're going to keep it. But I want to migrate to this SDN cloud architecture in my existing data center. All three of these customers had layer 4 firewalls. So they were motivated to do this by being threatened with litigation. A lot of customers sort of deal with security problems when they need to. And often a breach and a lawsuit is a good motivation to do this, right? All three of these have that scenario. All three of these implemented whitelisting, and all three of these implemented what we call dynamic address groups, this idea of writing policy based on tags. So by the way, this tagging concept has been around now for, I think, 6 years. We've supported it for a long time. It's only now become important. And all of these architectures involve both virtual and hardware firewalls. So people often emphasize the fact that we're virtualizing network resources, we're tunneling, we're doing all this virtual stuff. But hardware firewalls are always going to be in the picture, at the very least at your perimeter. Okay, so this is both. So this is solution one. This is NSX. Basically, this is moving the network decision processes up into the systems layer. So I describe SDN as one question with more than one answer. If the question is, how do I virtualize my network? This is one way of doing it, which involves zero changes to your physical network. So this is actually, in some ways, the least disruptive solution. I have a hypervisor, and I have virtual routing, and virtual switching, and virtual firewalling, and virtual load balancing, all going on up here. And if I want to create a path from here to here, from one host to the other, I no longer need to rely on VLAN decisions. In the traditional network, a packet leaves the host, hits a top-of-rack switch, and now you're relying on the VLAN or routing stuff going on, of which VMware would be blind to. But in this case, I want a packet to go from one to the other. I encapsulate that into VXLAN headers, and now the core simply needs to be fast, but dumb. All they're looking at is the headers. I need to switch as quickly as possible from here to here, and then it reaches a destination, the headers are stripped off, and the packet resumes its journey. So this means that the network team can now focus on traditional networking things like traffic engineering and redundancy and high availability. But it does mean that now routing decisions are now happening somewhere outside of your control. But the customer chose this because this meant they did not have to change their network architecture into some spine leaf thing, which involved buying a lot of new gear. Our firewalls in this architecture are implemented directly in a hypervisor, and this implements a true zero trust model. Because the packet is born, policy is applied to it at step one. We want the first step in the life of a packet to be policy, regardless of the architecture, if possible. We don't want to add complexity. So in this case, we're actually not doing any routing. We're not doing any layer 2 or layer 3 decisions at all. So this customer liked that because the firewall had zero impact on network details, and their physical network did not need to be re-architected at all. They had hardware firewalls at the perimeter, and Panorama is talking to the controller here, and any changes going on here are synchronized to the hardware firewalls down here. So even though the hardware firewalls were not participating in the virtualization, it had complete knowledge of what was going on. So a packet could enter the data center, the perimeter, going to the virtual realm, but a decision is made locally. Okay, so customer one chose this because it involves 0 changes to their network. Now, in this scenario, the systems teams had enough clout to do that. Networking teams often don't like this idea, so they will implement this idea. Now, this is basically how ACI works, and to a certain extent how Arista CloudVision works. This is basically the same approach, but reversed. So ACI will do this from a hardware layer. So we will implement tunnels, we will dedicate resources to application and storage, and we will deploy firewalls centrally. So this idea requires a spine leaf clause architecture, and you have certain dedicated service leafs, of which layer 4 through 7 devices are deployed. So all your load balancers and firewalls and web caches all go here. And now as I want traffic from site 1 to site 2 to go through a firewall, you have to somehow stitch that through a Palo Alto. And then we have a way of doing that. With NSX, the APIs to do that are already present in their controller. To do this in ACI, you have to download some middleware to do that. But in either case, it's an API-driven model. Their controller is talking to Panorama, or the NSX controller is talking to Panorama. So if you were to implement these both at the same time, you have to decide who's making what decisions. But this is, to me, the same idea, just reversed. In Model 1, we reside within the virtualization layer. In Model 2, we are a hardware device. But in the end, we're receiving packet, just the plumbing is different. OpenStack, people often choose OpenStack because the other two options are expensive. This is not really a cloud option. This is an automation story on top of which other controllers can reside. So in this customer's case, they deployed Nuage. So Nuage is the Alcatel Nokia controller to provision both physical and virtual workloads. It relies on OpenStack to automate the life cycle up to a point of virtual instances like ours. So we have virtual firewalls, which can be deployed on KVM hypervisors. OpenStack manages all of that bootstrapping and magic that goes on at that layer. And then Nuage tags workloads and sends it to us. So at the end of the day, we were sort of agnostic to what's going on in whether it's Nuage or NSX or ACI or OpenStack. We can interact directly with the OpenStack layer, which is largely a Nova-centric API story. Customer 3 did this because it was open source. Their priorities here is that they wanted no vendor lock-in, they wanted an open standard modular approach, and they wanted a full zero touch. So in this case, bootstrapping is very important. They want to be able to deploy a firewall image using Glance, have that firewall boot itself up, license itself, come to life, and talk to the right tenants with zero touch. And this works. We have reference architectures for all three of these that go into great detail. But this shows that you can choose a particular vendor or build it yourself, and we will interact with it using the same common themes: APIs, tunnels, tagging. So the checklist to do this, if you're going to do this on your own, these are the broad steps that you need to focus on. Instead of choosing the technology first and then the security, define your security boundaries first, before you even worry about the technologies. Who can do what to whom, when, and where? Just define those boundaries. Too often, if you buy ACI or you buy NSX or you stick to traditional route switch, you're implementing the technology and not placing potential limits on what those boundaries are. But in this cloud world, everything is abstracted above the physical layers. So define those boundaries first, and then choose a technology that most easily implements that. NSX does true microsegmentation, where every single workload is a segment. ACI uses more traditional networking boundaries. Arista lets the firewall define the topology. But the first decision is my security boundaries, then technology comes second. The operational question really is who is going to be who's going to be supporting this? Is this going to be a system-centric and system-supported model like NSX, or is it going to be a network-centric model like ACI or Arista? And now, again, this is a political choice, but often customers are convinced of the technical wisdom of both, but who has the most political clout? Okay, we are agnostic to that, but that's a decision you'll have to make. Some customers have this idea of a white box future where they're not going to buy any hardware devices at all. No physical routers, no physical switches, just SDN all the way. And I've dealt with 3 customers like that, and they usually back off after a while. this idea of, it's kind of a pipe dream where everything is a physical white box, everything is virtualized, and everything will be fully automated. The problem is, as soon as you virtualize anything, that's always slower than that hardware equivalent. So any virtual router is always slower than a hardware router. Our virtual firewalls can push a lot. Our highest end VM firewall can push up to about 16 gig of traffic, but our hardware can push 200 gig of traffic. So make that decision. Are you going to follow that SDN idea where everything is virtual? Most likely not. You're going to have a picture that involves both hardware and virtual. When we expose when we fit into the automation picture in something like ACI or NSX, often we're letting that fabric deploy our firewall or decide where that firewall will exist. So for instance, ACI. At the end of the day, when we're exposing the APIs to that fabric, we still usually want to ensure that after we have automated the deployment, the firewall is managed by the security team and the systems environment is managed by the sysadmins. Or do we want to expose, now that the firewall is living in a systems environment, do we want that firewall open to sysadmins to play with? Generally, the answer is no. But there are some vendors that follow the opposite approach. We will automate everything, and now here's my firewall. Anybody can now manage me. Systems people, storage people, whoever. Generally, PCI audits don't like that. Security devices are locked down for a reason. So only the security people manage it, whether it's a piece of hardware or it's virtualized and living in a VMware environment. You have to still guarantee that the right people are managing it. But realize there are other approaches out there. Some people like to have a single pane of glass and have everything happen centrally. But now you have to ask operational questions. Is that really a good idea? And again, tags. Don't define policy based on IPs. This just will not scale. Okay? Just get familiar with this idea. This is present on our virtual firewalls and our hardware firewalls. So I often encourage customers, if you have a hardware firewall, turn on dynamic address groups and just play with it and get familiar with the concept. So then later when you implement one of these solutions, it's not a new idea. And envision the future, right? The future is that you have private cloud, public cloud, multiple data centers, and things are flying around all over the place. There's VXLAN tunnels everywhere, and you can never predict where your data is going to be. Assume that, I've never seen that, by the way, but that's the way a lot of people talk. But assume that future. If you put firewalls in those environments and write tag-based or metadata-based policy, you're now ready for that future. So now no matter where that stuff resides, your firewall policies do not need to be constantly updated or potentially break traffic. So keep in mind this multi-cloud future, even though it may not exist yet. Which is that. So I see people often draw pictures like this. Now, I've exaggerated it a bit on the bottom. Generally, in the data center, you're going to choose one of these architectures. But if the top icon represents Panorama, each one of these environments has a controller. Each one of these can tag. And if they all agree on the tagging conventions, Panorama can be the central point where forwarding tables are updated in the background, but policy remains static. You write policy once, and then you don't change it unless some new services are needed. So this is, I think, my last slide. We have some resources online to help you with this. The first is if you go to Palo Alto's website and search for reference architectures, we have very detailed reference architectures documents for NSX. We have very detailed real-world architectures for NSX. OpenStack resources. There's a lot of stuff out there. I would also recommend looking at some of our Lightboard videos where you have people talking and drawing on transparent glass, showing you some of these workflows, because these details can become very complicated. So we want to be able to step back at some point and try to understand what problem we're trying to solve. We have a lot of this on GitHub. If you go to the GitHub Palo Alto section, you'll see a lot of scripts, a lot of Python, Perl, PowerShell tools where you can script all day long. But we've also written the Pan device tool, which is a way to use an object-oriented approach to make scripting much more efficient. Okay? So with a lot of these controller-based environments like ACI, you're going to be interacting with it via scripts. So there's a lot of Python going on. We want to be able to consume data from those same resources. So you can get a lot of, I've just kind of touched the surface on these details. You can get a lot of detailed information from real-world customers from these resources. So I think I've hit exactly the right time to end. Are there any questions, or is this completely simple?
So I guess I'm less ambitious. When I hear this tagging thing that
QoS?
So how about, I mean, if Palo Alto would allow me to write rules based on DSCP value, I could just tag it right from the server level.
So this is not,
Distinct rules,
right, so the question is about QoS. This is not a tag in the frame level itself.
I understand that.
Okay.
What I'm saying is if I could write firewall policy by a tag at the packet level, I could say anything with this DSCP value, this DSCP value, or whatever,
Right.
permitted.
That would be sort of an expansion of the tagging concept. I don't know why we don't. I'm sorry. The question is, if we're going to create these new ways of writing rules based on like tags, why not expand it to something like DSCP values, the QoS values in a packet? So write a rule that says that DSCP value 1 can talk to DSCP value 2. I don't quite know the answer. That's sort of an engineering decision question where we want to sort of move away from the networking layer. Like that would not work in public cloud because we have no visibility into that. Like Amazon doesn't expose that information, right?
So your server, you control any part of the server. You can tag the packet as an aggressive tower.
Okay, it's a very so also it's a networking specific question. So when you talk to systems teams, they may not know what a DSCP value is, right? So our goal largely is to try to be as agnostic as possible so that both teams understand this concept. There's no reason we couldn't do that probably. We just don't because we want to be, I just use the word agnostic a lot. It might be a feature request. If you think, if you have a lot of money to spend, maybe we'll implement it. But that might be why.
I just wanted to ask if you are equally competent in systems and networking, is there a cost benefit or to going a systems-centric approach versus network-centric approach? Like if you went with NSX versus ACI, and you're buying one or two big firewalls versus lots of little firewalls, is there a...
So the question is there a cost benefit to either of these architectures? Do you mean from the firewall perspective or the? No, we actually don't price it based on architecture. Like VMware, like NSX is, the licensing is based on how many sockets you have.
Right.
We don't do that. So if you put a virtual firewall in ACI or you put a virtual firewall in NSX, it's exactly the same price. So there is no cost difference from our firewalls on any of these solutions at all. Exactly the same. Again, we want to be agnostic.
Exactly.
Right.
Total SEN newbie.
Okay.
Just trying to understand. If you have, I guess, pros and cons in regards to microsegmentation and having virtual firewalls, if you could switch traffic,
What, pros and cons for microsegmentation?
or against having virtual firewalls that are
So I understand your question. Are there pros and cons for having a firewall in that environment or not? Is that what you're asking?
as opposed to just straight Microsoft.
Well, if you have, okay, so NSX, for instance, so the question is, are there pros and cons to microsegmentation in terms of security? So that term was invented by VMware, right? And it refers to their tagging-based method. So that is, in their environment, tagging is, they use the tags to make forwarding decisions. And they have a firewall, but it's layer 4, right? So some people argue, well, I'll just use that. So there's two answers to that question. One is layer 4 is not going to get you very far. If you don't put a virtual firewall in an east-west microsegmentation environment, it's a question of visibility. You're just going to be blind to this traffic. And most systems people prefer to spin up VMs than to deploy new physical hardware. So the pros of putting a virtual firewall in that environment is simply to extend visibility into that environment. We want to avoid blind spots. A lot of data centers today have blind spots. If I can somehow introduce malware into that environment and I have a hardware firewall out here and I'm doing all this east-west damage, that firewall never sees it. So the underlying reason for putting a security into that environment is just to open the doors and be able to see what's going on. If I understand your question correctly. The cons, I guess, would be, see, we have one OS. Cisco has, what, 15 software trains? We have one. So all of our firewalls work exactly the same, hardware, virtual, everywhere, except the only difference is in NSX. Because we're residing above the forwarding plane, the packet hits us before it hits the network stack. That means our firewall does zero networking. So if you look at the network tab and you'd expect to see BGP, it's just empty. So the only cons would be that maybe operationally you have to keep that in mind. But the broader benefit is you want to see what is going on in your network. Do you want to be blind or not? That's the question. So the question is, would you use it just for threat prevention or ACLs? Generally, you want to have one default policy inspection globally, whether it's your hardware or virtual firewalls. So that question sort of assumes the old school model of at the perimeter, I need to have really good inspection. But the deeper I get into my data center, the more trusted it is. So all I need is threat prevention, or all I need is URL filtering. Part of the zero trust model is across the board, from perimeter to source, have exactly the same thing. So yes, some customers will do that, assuming the old model, but we want to push the new model where we have one fabric, and from end to end, we have the exact same policy. So we would encourage people to do whatever threat you're doing at the hardware firewall, do the same threat in the virtual.
Yeah.
Running out of time?
No, I just wanted to sort of add some context to the question too. Typically, what we see, the three main use cases which drive the insertion of our firewall, virtual firewall, on top of a microsegmentation model which exists on VMware. Our first one is deep visibility, which Krista talked about. And what do we mean by that visibility? What we are focused on is rich contextual information which you gain by looking at the traffic which is traversing between application to application. Mostly layer 3, layer 4 information is available to you if you just do microsegmentation on the NSX side. But if you want to look beyond that and understand what this is actually happening from an app-to-app health activity perspective, behavioral perspective, that's when a virtual firewall insertion makes sense. The second main driver tends to be threat prevention and wildfire, as you mentioned earlier. The primary motivation, of course, is to make sure that you're protecting the app workloads from known and unknown threats. That's one rationale. The other common use case which we see also is a quick way to stop any known CVEs from being exploited, right? That's the other driver. The third driver, which actually we have seen quite a bit in recent times, is how consistently can we enforce a security policy across multiple locations of NSX deployments, especially multi-site, multi-data center deployments. You want one consistent security policy to be implemented across them. Today, we are the only ones who are actually kind of doing it from the top. So that's one of the other use cases which we have seen, where consistency across different locations also is a main driver for inserting our virtual firewall across these NSX deployments.
By the way, this is Sai. He's a product manager, as you can tell. Okay, one more.
Is there any approach where, we can, as a security operations team, lead some kind of left to the security and network teams to perform some operation inside the firewall?
Yeah, so the question is there a way to let networking teams and security teams sort of cross boundaries, to let some do some work and some do others? Yeah, that's an operational question. So on our firewall, you can create, users. So if I wanted to do that, and there's a networking team, I could create user accounts for them and give them access to only very specific security functions. So it's kind of like sudo in Linux, right? So yes, you can. By default, we want to close the doors and have only the security team and only the networking team. But if you want to expand those trust boundaries, sure. But it's done at the user account layer. User X can do this. User Y can do that.
Just want to add some color to that. It's a great question, actually. This is something which has come up in recent conversations with some of our customers, too. And that is what sort of insight we can provide for network teams from our firewall, right? It's easy for security teams to sort of glean whatever data they want out of the firewall, but what is the network-centric view of things, and how can network teams benefit from the firewall information itself? So we actually have a full-fledged XML API available for you, available from the firewall itself, which you can use to query and collect data. A good example of this in recent times, which I heard from a customer, was they were querying the firewall to get information about what kind of sort of data was being exchanged between two different applications in terms of how much data was being exchanged. So they actually had literally TX and RX packet counter information being sent out through API. And that information was used by the network teams to understand the health of the application itself. How much data was being exchanged from app A to app B, and why was more data being sent from app A and less data coming out of app B. So that sort of health information also can be gleaned from the firewall itself, which may not necessarily be available in detail from the other logging mechanisms available at the SDN layer.
So you would look at our API design guides to do that.
ACI environment, in order to steer the traffic to the firewall, you can either use the service graph or use layer 2, layer 3 opt.
Right.
So compare these two options, what's the pros and cons?
Well, with ACI, so the question is, with ACI, you're using service graphs, which is a template, and layer 2 or layer 3 out to a device and then back in again. Cisco's guideline, so with NSX, VMware has created a new proprietary protocol to do microsegmentation above the network. They created something new. Cisco's approach with ACI was to not do that. Let's stick with traditional networking concepts. Now, they'll use the term microsegmentation, but if you look at it closely, they're creating just lots of really small traditional network segments. So the pros in that is that as a networking team, you're familiar with those concepts. Now, you have to do everything via the controller. Now, from my background, I love CLI. I want to be able to connect to a Cisco switch and type. I can't do that. I have to do everything through the stupid controller, and then it pushes everything out. So the cons are you have to sort of learn how to do that, but your concepts are the same. You're not, with NSX, you have to know what the NetX API is doing. You have to learn something new. So the pros are it's a familiar scenario, but the cons, I guess, would be that it's not, that you're not really getting true microsegmentation in the sense that NSX is doing. Now, in my experience, people are not generally. So some people look at NSX and say, that's great, but I don't really have thousands of microsegments. I have maybe 3, app, database, web. So I can get by with ACI and create those segments. So it's really kind of a philosophical argument. What, do you want something familiar or do you want something new? And how do you want to manage it? That's usually the questions I hear people ask. We don't care. I mean, from a security perspective, we'll consume the information from either side. I would say ACI is very complicated, though. I've seen a lot of people, actually that example where somebody migrated for 20 seconds and took 12 hours to remediate, that was an ACI deployment. Just saying. Anything else? One.